Okay, so here we are on quiz number 8. They want me to find the 85th term of this sequence. Now, what's happening from term to term here? Notice it's adding 1/4 every time, isn't it? Right, because a half, that's 2/4. So it's 1/4, 2/4, 3/4. It's adding a fourth every time. So that means it's an arithmetic. Because if you're adding or subtracting, right, if you add, subtract the same number each time, that means you're in arithmetic sequence. If you multiply the same number every time, you're geometric. But we're adding the same number every time. So I'm going to use the arithmetic formula. AN is A1 plus N minus 1D. And so AN is A1. That means the first term, which is 0, plus N minus 1 times D. What's the D? This is the D. The D is the 1/4. Like that. Okay, in fact, let's just make it a decimal. That'd be easier. 0.25. Right, 1/4, quarter of a dollar, 25 cents, 0.25. So now I want to find the 85th term. 85th, the ordinal numbers. 85th is what we call an ordinal, meaning it implies an ordering. It doesn't just say 85, it says 85th. When you have that TH, that means it's implying in what order, and that's always in. So 85 goes right in there for in. So the A sub 85 is 0 plus 85 minus 1 times 0.25, which is 0 plus 84 times 0.25, which is, isn't it? Yeah, 21. It is 21. There we go. Okay, so here's number 2. Fifth term is minus 21. 15th term is 39. Okay, so let's try this out. So the fifth term is minus 21. 15th term is 39. So how far is it from the fifth term to the 15th term? 10 terms away. 10 jumps. And how far is it from there to there? If you subtract 39 minus 21, you know, how far from there to there, you'll get, what's that, 39 plus 21, 60. You'll get 60. So that means it goes up 60. So in 10 terms, 10 jumps, it goes up 60. So that means the D is 6. It's 60 over 10, which is 6. It goes up 60 in 10 jumps. So each jump is 6, right? If it's going up from negative 21 to 39, it's going up 60 in 10 terms, from the 5th term to the 15th term, 10 jumps. Then 60 over 10, 6 per jump. So I've got the D. So now let me write the A sub n formula. A sub n is A1 plus N minus 1D. So I've got the D is 6. And now I'm going to try to find the A1. How do I do that? Well, fifth term is negative 21. What can I do with that information? Fifth term is negative 21. Remember, fifth is an ordinal, that's n. So if you plug in a 5 for n, 5 right there for n. The D is 6, as we said. And what is the fifth term? What is A sub 5? It says right here it's negative 21. So negative 21 plus, this is 4 times 6, 24. How do you solve for A1? Subtract 24. Boom, what's that? Minus 45. A1 is minus 45. So the first term, minus 45, the common difference, the D, is 6. Let's go to a fresh screen here. Okay, so we get, again, the first term is minus 45. The common difference is 6. Now, A1, they want a recursive formula. A1 equals what? Well, you're just adding 6 every time. So it is, well, I'm sorry, A1, this is minus 45 right here. That's A1. And AN is the previous term, add 6 every time. That just goes right there. Because what that says is any term is the previous. That means previous. In minus 1, 1 back. Any term is the previous term, add 6, right? That's what the D being 6 means. It means we're adding 6 every time. And what is the formula for the nth term? So last thing here, A sub n, again, is A1 plus n minus 1D. A1 is minus 45. D is 6. Distribute. 6n minus 6. An minus 45 minus 6. Minus 51. There it is. Minus 51 plus 6n. We got it. Okay, so this summation formula they're giving me here, this means add up, that's a big Greek S, sum up, add up this formula as we start at 1 and end at 120. So plug in n equals 1 to this formula. 3 times 1 minus 4, putting in a 1 right here for n. What's that? Negative 1. And then plug in 2. 3 times 2 minus 4, that's 6 minus 4, 2. Then plug in 3. 3 times 3. Just getting a little scribbly there. 9 minus 4, 5. And we're adding these up, etc. What's the last one? We end at n equals 120. So that's 3 times 120 minus 4. 360 minus 4. What's that? 360 minus 4. 356. So there we go. So this is what we're adding up. Now, how do we figure out what those all add up to be? That's an arithmetic sequence. See what it's doing every time? It's adding 3, adding 3. So then I'm going to use, so it's arithmetic. So I'm going to use the S sub n, because it's the sum, right? So n over 2, A1 plus AN. So n is the number of terms. A1 is the first term. AN is the last term. So what's the number of terms here? Well, it must be 120, because we started at 1, 2, 3, all the way to 120. So there's 120 terms. What's A1, the first term? That's the negative 1. What's the last term? That's the 356. So work that out. That's going to be 60 times what? 355? 356 minus 1. So I'm going to use my calculator here. 60 times 355. I'm getting 21,300. There we go. There's the sum of that sequence. Okay, number 4, same kind of thing. I'm going to start with n equals 1. Plug in 1. You get 4 minus 1/3 times 1. It's a little ugly. Got to use fractions here. So that's going to be 4 over 1. Common denominator, multiply top and bottom by 3. 12/3 minus 1/3, 11/3. Okay, I guess we're going to be dealing with fractions here. Plug in 2. Going to get 4 minus 1/3 times 2. Same kind of thing. Put it over 1. Top and bottom by 3. 12/3 minus 2/3, right? Because it's 2 over 1. So that's what? 10/3. Plug in 3. 4 minus 1/3 times 3. That's 4 minus 1. That's just 3. That's easier. We're adding these up. Dot, dot, dot. What's the last one? Dot, dot, dot. N equals 90. We start at 1, end at 90. So plug in 90 there. We get 4 minus 1/3 times 90. 1/3 of 90 is 30. That's minus 26. Okay. So there's the sequence of numbers. What's happening now? What's going on from term to term? Can you see that it's subtracting a third? Because 11 thirds minus 1/3 is 10 thirds. Now you think, well, how does it work here? Well, 3 is really 9 thirds, isn't it? So it's 10 thirds minus 1/3 is 9 thirds, which is 3. So it's just subtracting a third every time. So let me go to a fresh screen here. So what do we have? We have 11 thirds plus 10 thirds plus 3 plus dot, dot, dot. And the last number is negative 26. So every time it's going down by a third. Okay. So what are we going to do? How do we add? These are all added up. It's the Greek S, so we use the S sub n formula. It's arithmetic. Why is it arithmetic? Because it's adding or subtracting. Arithmetic is adding and subtracting the same number every time. So the n over 2, a1 plus an formula. All right, so let's work that out. N, what is n? Now, do you know what the different pieces are here? Number of terms, first term, last term. So what's the number of terms? 90, because that's the last one, right? That's where we end. We start at 1, end at 90. So there's 90 terms. What's the first term? Let me clean that up a little bit. What's the first term? First term is right here. 11 thirds plus, kind of scribbly there. Plus, what's the last term? Negative 26. So there we are. We need to figure that out now. A little messy, huh? So that's going to be S sub n. 90 over 2 is 45. 11 thirds plus a minus. This is going to be minus. Put this over 1. Multiply top and bottom by 3. 3 times 26, 60, and 18, 78 thirds. And so subtract those. It's 11 thirds, so it'd be minus, what's that? 67 thirds. Right? So you can just multiply that with your calculator, and let me see, what are we going to get? Negative 1,005. Negative 1,005. All right, so here we are with Drury Lane Theater. 19 seats in the first row, 34 rows in all. Each successive row contains one additional seat. So what are they talking about? They mean like the first row has 19 seats. The next row, let me make this a little better, has 19 seats. The next row has 20. The next row has 21. The next row's got 22. The next row's got 23, etc. It's like pyramid seating. It gets wider and wider. One more seat. Now, how many rows? 34 rows. So basically what they're saying is you're adding up the numbers 19 plus 20 plus 21 plus 22, etc., and you have a total of 34 numbers, right? Because they want to know the total, how many seats total in the theater. So there's 19 seats in the first row, then 20, then 21, then 22, 23, etc. Add them all up, 34 different numbers, because there's 34 rows. Find out what the total is. Well, how am I going to do that? Well, we got to use, that's an arithmetic sequence, right? Because it's just adding 1 every time. So going to use the S sub n formula, n over 2 a1 plus an, whoops, making those a's kind of look like 9s, a1 plus an, okay? So this is the number of terms, first term, last term. So what's the number of terms? Let me go to a fresh screen here on this one. So we have S sub n, n over 2, a1, an, number of terms, first term, last term, and we're adding up the numbers 19, 20, 21. Dot, 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 and we have how many total numbers? 34 numbers. Okay, so S sub n equals, how many terms do we have? 34, right? There's 34 numbers there. First term, well, that's 19. Last term, I don't know. How am I going to get it? A sub n? How are you going to get that? We have an A sub n formula. You're going to have to use two formulas on this problem. It's a hard problem. All right, so to find A sub n, A1 again, which is 19, plus n minus 1 times d. What's d? D is the difference from term to term. D equals 1. We're adding 1 each time. And what's n? What n is the number of terms. Remember, there's 34 terms. 19 plus 33 times 1. Add that up. That's an A. My A's just start looking like 9s. What is that? 33 into 53, 52. So there it is. Take that, bring it back here. 52 is your A sub n. Now we can finish this problem. This is 17 times, what is that? 71. 17 times 71. 1,207 seats in Drury Lane Theater. Okay, so number 6, write a formula for the nth term. So what's happening from term to term here? This one is multiplying by 2, isn't it? Times 2. So that means it's geometric, and the A sub n formula is A1 times r to the n minus 1. So A1, the first term, is 3. Times r, the r is the 2. It's the number being multiplied every time to the n minus 1. So 3 goes here, 2 goes here. That's all they want. Next one says find the nth term. They're giving you the 6th term and the r. So again, it's geometric. Again, A sub n is A1 r to the n minus 1. So they're telling me 6. I can plug in 6 for n. And A1 times r, the r is negative 4, to the n minus 1. Again, n is 6, so plug in right there 6. You see, maybe if I change the color, that'll make it more clear. See how this is 6, and this is 6. N is 6. So then, A sub, and what is A sub 6? Yeah, let me keep changing my mind here. A6 is negative 1024. It says negative 1024 equals A1 times a minus 4 to the 5th. What is minus 4 to the 5th? It's 1,024. So then if you divide both sides, oh sorry, it's negative 1,024 because 5th power, 5 negatives is negative. So divide both sides by negative 1024. Boom, you're going to get A1 is 1, isn't it? Because this over this is 1. So A1 is 1. So I've got the formula now. It's 1 times r minus 4 to the n minus 1. Right? Because it's A1 times r to the n minus 1. A1, which I know is 1, times r minus 4 to the n minus 1. So number 8 here. Okay, so summation notation again. This is S. So start at n equals 1, end at 15, plug in 1, plug in 2. Plug in 1, you get 5/14 to the 1. Plug in 2, you get 5/14 to the 2, etc. So what's happening every time? What's the, well, let's write the formula. So here, I need more room. So it's the sum from n equals 1 to 15. 5/14 to the n. N equals 1. It's 5/14. N equals 2. It's 5/14 squared, etc. So the formula for S sub n, because we're adding these up, is A1 times 1 minus r to the n over 1 minus r. That's the S sub n geometric formula. So it's A1, first term, 5/14, times 1 minus R. Now what is R? How do you find R? R is always the second term over the first term. Second term over first. So it's going to be 5/14 squared over 5/14. Now, how do you do that? Well, remember when you have like x cubed over x to the first, you subtract powers, right? Top power minus bottom power when they're vertical. That's what we have here. These are the same bases. Subtract power 2 minus 1. So that's going to be 5/14 to the 1, or just 5/14. So that's my R. 5/14. This one's to the n. Now what is n? N is the number of terms. 15, huh? So that's 15 right there. 15, like that. Okay. Okay, so now you should just enter this into your calculator. I'll do it right now as well. So be careful about it. I'm getting 0.555 forever. Do they say 3 places? 3 decimal places. So it's 5555. It just keeps going. So if you want to round to the third place, look 1 to the right. So that rounds it to 0.556. So if you have trouble getting this on your calculator, that's just all by calculator, I'm glad to help. Come to office hours. I can show you how to type that in to your calculator. You basically, the main thing is you got to put parentheses around the numerator, parentheses around the denominator, like that, to get that to work. So, and then it'll work. All right, let's try the next one. So this one is infinite. It goes on dot dot dot. So we got to use the S of infinity formula, which is A1 over 1 minus R. So what's A1? First term, 5, 1 minus R. Now what's R? R is always second term over first. Second term, be careful here now. Second term is minus 1/5 over first term, which is 5. How do you do that? What do you do with that? Well, this is 5 over 1. Flip it up. So we get what? Minus 1/5 times 1/5, which is minus 1/25. So there's the R, like that. Double negative becomes positive, so we get 5 over 1 plus 1/25. You could just type that into your calculator as well. And I get the, oh, they want a fraction, so we can't do a decimal. All right, better do a fraction. So put this 1 over 1, multiply top and bottom by 25. So we get 5 over 25 25ths plus 1/25, which is 5 over 26 25ths. And what do we do with a fraction in the bottom? Grab that, flip it up. So it's 5 over 1 times 25 over 26, which is 125 over 26. Okay, so number 10 here. What's going on? So we have 5, 7, 10, 14, dot, dot, dot. What's happening? It's adding 2, adding 3, adding 4. So that's neither. Because it's not adding the same number every time. It's not multiplying the same number every time. It's neither. So there's not a common difference. It's not arithmetic or geometric. And that's all for that one. If it was adding the same number every time, it'd be arithmetic. If it was multiplying the same number, it'd be geometric. But it's neither.